Okay, hey guys, this is the videos. These are the videos for tutorial 6. Before we go into anything too much in depth, I just wanted to briefly go over some things on the midterm. As you're all aware, the average was, I think it was 18, and the standard deviation was 4. Normally, why am I using pen? Normally he expects the average normally to be about 20 or above 20. So the scores for this exam were definitely a little bit lower than expected. I think part of the issue is on my head. Regarding the dex on the tension and compression members, I should not have said ignore the dex. I said ignore the dex because I was looking at the solution for last year's exam and he didn't have the dex marked in any of them, but it was because in those cases the dex were not obvious. If your deck is obviously in tension or obviously in compression, then you should include it. Other than that, though, that would have probably raised the average by maybe a point at most. So this would have gone to 19, and that still doesn't explain a couple other things. I'm not sure where the points were lost, to be perfectly honest, because I don't have a breakdown of what the exam was like, but I have a feeling that it was either the tension and compression members and probably the frames. So if we were just to go over the issue with the frames very briefly here, I think the issue that was confusing a lot of people was this overhang. You have a hinge like this or something. I don't remember what the exact loadout was, but you had something that looks like this. And I think you had a load like this. And as far as I remember, this force here was 0 for almost all the cases, if not all the cases. The idea here is, remember that when you're working with a hinge, you take the moment at the hinge, you just look at either the left side of the hinge or the right side of the hinge, and you can do your sum of forces. So your normal equations are Fy mz. These are global. You must use these on all your members. Your moment about the hinge, so let's call this A, B, C, and D. You only need to look at sum of moments on one side or the other. You do not need to check both of them. That's what distinguishes this MZ from this MH. MH. If we apply this to our problem, if we take the moment about the hinge here, we get dy equals 0. As a matter of fact, unless we have a load between the hinge and the roller, dy will always be 0. So that was the main thing that was throwing a lot of people off. I think last year there was no hinge on the problem. I can't remember exactly what last year's exam was like, but the hinge was throwing people off, and I think having the load right at the hinge was throwing people off as well. Remember that having a load at the hinge doesn't actually do anything to your problem except give you this extra condition. So you can have shear going through here. You could have shear that looks like this. You could have a moment diagram that looks like this. Like it crosses 0 right at the hinge, but everything else is perfectly normal. The hinge doesn't change that much in your question or in your solution. If you'd like to talk about the exam, you can feel free to stop by. I cannot make point corrections to your exam. The professor has to make those point adjustments. And if you have questions on the actual grading, see the professor. If you have questions on how to do part of the problem, then you can stop by and see one of us. One of us meaning the TAs. You can avoid the professor. The professor is usually actually very busy. right now because we're going through ABET accreditation. But yeah, I think that's everything. So I'm gonna go over tutorial 6 next.